Hello, everyone, and welcome to our webinar on scaling GenAI use cases for your most demanding needs. I'm Gabriel Campos, a solutions architect at Nexla, and today I'm excited to talk to you about how Nexla's advanced RAG framework can help you scale your GenAI use cases. And I'll show you how Nexla's capabilities streamline data integration, enhance AI workflows, and empower your teams to innovate faster. So let's kick things off with a quick introduction to Nexla. Our mission is simple: to provide ready-to-use data for a variety of applications. Whether it's for GenAI, analytics, or operational needs, Nexla is incredibly versatile. Think of it as your all-in-one data integration platform, supporting everything from traditional ETL and ELT processes to real-time streaming and API integrations. We work with companies across diverse sectors: finance, healthcare, retail, and more, to help them manage complex data landscapes. Whether it's ingesting and processing terabytes of data or integrating various data formats, Nexla handles it all with ease, ensuring that your data is always ready to use. Our platform flexibility allows organizations to adapt quickly and scale their data operations without being locked into rigid vendor ecosystems. Now let's talk about Nexla's Data Plus AI integration platform. What makes Nexla truly powerful is its ability to bring together data from a wide variety of sources, whether they're operational systems, SaaS apps, on-premise applications, or even external data sources like unstructured GenAI data and third-party APIs. Nexla's platform allows you to create a seamless flow of data between these diverse systems, transforming and preparing it for use in downstream applications. Whether it's data warehouses, data lakes, or marketing systems, Nexla ensures that the data flows run smoothly and are always in the right format for your needs. So one of the core components of Nexla platform is its metadata intelligence. This is what we call our data fabric. It's a layer that automatically assembles data products from your existing data and constructs what we call a nexet. Think of it as a smart intermediary that understands your data, how to prepare it, and how to make it ready for use. Nexla's auto-assembled data products allow you to integrate data from multiple sources and transform them without writing a single line of code. And this is where our concept of composable data and workflow integrations comes into play. I like to think of Nexla as a set of Lego blocks. You can assemble different components to create complex data workflows that are easy to manage and modify. This composability is key to building flexible and scalable data operations. Now let's shift focus a little bit to how we can build enterprise-grade retrieval augmented generation systems with Nexla. So at its core, RAG has three prerequisites. First, ingesting data, then creating embeddings, and finally storing them on a vector database. Nexla simplifies this entire process. First, it handles the ingestion of diverse data types, being documents, web pages, structured data, and more. Then, we automatically chunk this data into manageable parts that can be easily processed. We create embeddings using an embedding service or function like OpenAI's API, transforming textual data into numerical vectors. And finally, we write these embeddings to a vector database where they're ready for fast and efficient retrieval. And then, once your data is in the vector database, Nexla's platform enables real-time workflows to leverage large language models. And here's how it works. As you can see, a user query is instantly converted into a vector when it's received by a Nexla webhook. Then it's matched against vectors sitting on the vector database to find relevant information. This data is then stitched into a context that the LLM uses to generate accurate and contextually rich responses. Nexla makes this entire process seamless, ensuring that your data is always up to date and accessible for real-time AI applications. This capability is particularly valuable for use cases like chatbots, customer support systems, and dynamic content generation, where the quality and relevance of the data are paramount. So, one of the biggest challenges in deploying RAG systems is maintaining data richness and quality. With a large number of documents and diverse data sources, it's crucial to keep the data up to date and ensure it's correctly indexed. Nexla addresses this with its advanced chunking strategies and pipelines that remember what data has been processed and indexed. This means you can run and compare different chunking strategies to find the most efficient one for a specific use case, balancing perform, cost, and quality. Another key challenge is ensuring your AI models have access to rich and contextually relevant data. Often, simply retrieving documents isn't enough, and additional context is needed to improve the accuracy and relevance of the responses. Nexla allows you to enrich your data with real-time and external information using our NextSet framework to bring in data from APIs, relational databases, and vector sources. And by doing this, we ensure that your AI models are not just retrieving data, but also understanding it in a way that enhances their responses, providing deeper insights and valuable interactions. With Nexla, building and orchestrating advanced RAG workflows is very straightforward. Our platform supports everything from query rewriting and classification, rerouting, and context enriching prompting, and real-time data retrieval. Nexla's orchestration capabilities integrate seamlessly with external services, allowing you to build robust, flexible workflows that can easily scale across different AI models and cloud environments. This composable architecture supports multiple models and algorithms, ensuring you're never locked into a single vendor. Whether you're using OpenAI, Google's Gemini, or Llama 3, Nexla provides the flexibility to choose the best model for each use case and dynamically switch between them as needed. So, scaling GenAI from prototype to production has never been easier with Nexla. We enable you to ingest and process data at terabyte scale across all formats and systems, from unstructured documents to structured databases. Our resilient pipelines are built with monitoring and notifications so you can keep track of everything that's happening in real time. Nexla also supports rapid experimentation and deployment, allowing you to integrate and test different models and data workflows without extensive coding. With cross-cloud data and workflow integration, you can leverage the best tools and models available, ensuring that your GenAI applications are always performing at their peak. So now let's jump into our live demo to see all of this in action. We'll start by ingesting public legal documents as PDFs and show how Nexla can easily chunk this data for processing. Then, using NextSets, we can combine this information with real-time data from the web and maybe structured data from SQL databases, which creates a rich and contextually enriched data set ready for AI workflows. So I'll demonstrate how we store this data in a vector database and query it using a chat interface that Nexla provides, and basically showcase Nexla's seamless integration and real-time capabilities. Finally, we'll also explore how to experiment with multiple models simultaneously, highlighting the flexibility of Nexla's platform to adapt to different use cases and optimize your AI performance. Okay, so now what you're seeing is the Nexla platform. Right now, I'm on the integrate section where I can see all of my data flows. Here, I created a specific project to showcase for this webinar where I got a bunch of legal documents on the Epic Games versus Apple legal court filing that has happened a little while ago. So I got all of these public documents on this specific case, and I've uploaded them to an SFTP server. And using Nexla, I was able to connect to this file system and instantly get all of the text context of each PDF file. So what I have here on my NextSet abstraction layer is basically the text and the text excerpts of every PDF document that I have sitting on my SFTP server. This can be easily chunked using different strategies. Maybe you want to leverage semantic chunking. Maybe you want to do per page chunking or a different strategy. So Nexla supports many different chunking strategies out of the box to make sure that for any AI use case that you're thinking of, we're able to cover it without exceeding token limits. So as you can see here, we have some samples of text excerpts that were grabbed from these PDF documents on the legal case of Epic Games versus Apple. And what I'm doing here is on a transformation that is built into Nexla, you can easily turn these text excerpts into vector representations. As I mentioned before, this can use any embedding service or model that you want to use. So Nexla is very flexible and you're not vendor bound when it comes to LLMs or vector embedding models or any external mechanism that you want to use for your AI workflows. So here, if I open up my Nexla rules, I'll be able to see a text to vector embedding transformation that is leveraging OpenAI's embedding service using text embedding ADA002 model. So basically what that does is it takes my text representation that I got from the PDF, and then out of a chunk of these excerpts, it turns it into a numerical representation, which is a vector that is suited to be inserted into the vector database. For context, we do that because vector search is much easier to do, and it accounts for the semantic understanding of the sentences. So if we were to do keyword search, that would be much less optimal because it's not actively accounting for the semantic and the meaning behind all the keywords that are sitting on this excerpt of text. So basically what I have on my text plus vector embeddings next set, which is basically a data representation and a logical representation of this data, is a hash ID that I'm hashing out of the text on the PDF document. Then on a metadata object, I have the text itself, the raw text coming from the PDF document. And on the values attribute, I have the vector numerical representation of that data. So once we have this, we can easily send it to Pinecone. So here on my destination side, I have a Pinecone index that I've created for that. But you could use any vector database out there. Maybe you want to use Weaviate. We have also a connector for that. And it's worth mentioning that Nexla is also a Pinecone official partner. So you might want to use Pinecone if you want as well. With a built-in connector out of the box, you can easily send data to Pinecone, vectorized data within a few minutes of setup in Nexla. So as you can see here, I have my index URL, and I'm calling the upsert operation on these vectors. This is especially important if your documents are constantly updated. So let's say you have a repository of many different PDF documents. You have your SFTP server or your FTP server, and then some document gets updated. In this example here, I'm using the text itself to basically generate the ID of the vector on the vector database. But you could use the file name or maybe the file ID if you have any. And then whenever this file gets updated, Nexla will pull all of those files every day or every 15 minutes, depending on your scheduling options, and then automatically vectorize all of these files and update their representation on a vector database. Meaning, whenever your users are asking questions to the chatbot, it always has up-to-date information on the data that is sitting on your file system as well, because Nexla is constantly retrieving them from your file systems and updating their representations on the vector database. So once we have this data flow created from source to transformations and destination, and all of that was done no code because from source connection to transformation generating vector embeddings to the destination connection, everything is supported out of the box within Nexla using native connectors and no code capabilities with our built-in transformations that leverage OpenAI services or any other embedding service that you might want to use. So within a few minutes, you are able to create this full data flow that ingests from your SFTP source into your Pinecone index for querying later. So I have this second data flow, which basically connects to my Epic versus Apple index on Pinecone. And this is the vector database index that holds all of the vectors and metadata for these documents. What I'm doing on this tab is basically creating a way of Nexla to easily query this data on the vector database. You're going to see how easy it is using Nexla chatbot interface to quickly put an ID, which is this Nextset ID, onto the chatbot interface and start asking questions related to things that are sitting on this vector database. And later, of course, if you want to connect to APIs, databases, different systems, you can easily create them as a source using Nexla, and then they would be instantly available on our chatbot interface. There, you would be able to easily mix and match multiple different next sets, which, as I mentioned before, are the logical representation and the abstraction layer that we create on top of your sources to be able to query them using AI or any LLM that you want to use. So as I created this source here, being in the exact same index on my Pinecone instance, I have my detected next set, which is basically an abstraction layer of everything that's sitting on that vector database. Um, Now I can copy this ID and go now to our chatbot interface. So here on the chatbot interface, I can authorize using my Nexla provided service key. And then here I have an interface to search for next sets and basically select them to perform effectively the RAG workflow on this chatbot. So here, what you'll see on this front end is basically what I've explained it before on the second step of the RAG workflow. So basically, Nexla will receive your query along with your selected next sets and will stitch information that is related to the user's query on the fly, send that to the LLMs of choice, and then get an answer back from them instantly on the fly within a few seconds. So on this screen right now, I can search for my next set, which is basically connected to my Epic versus Apple Pinecone index, which has all of these vectors and legal excerpts that I got from the internet. Now that I have this connected, I can start asking questions about these legal cases, and I have some ready right now. So I can ask, for example, what were the main arguments presented by Epic Games against Apple in this case? So now, basically, I've selected three different LLMs to answer the same question using the same context. So as you can see, OpenAI has a smaller response. Anthropic has a slightly more extensive answer, and then Mixtral has another type of answer. And this enables you to quickly compare and evaluate what would be the best LLM to use for your specific use case. So this chatbot interface is used for experimentation, but you can also explore your data infinitely, mixing and matching multiple next sets, as I mentioned before, and also different AI models. So maybe for legal documents, a Mixtral might be better than OpenAI, and for I don't know different medical documents or research papers, Anthropic or OpenAI might perform best. And that's why we want to provide you with a framework in which you can easily experiment and spin up tests and have a playground in which you can easily put your data into and let Nexla handle everything else on the RAG workflow. So as you can see, not only we get an extensive response from every AI provider, but we can also have citations of where they got this information from. So all of these documents and these document numbers, along with its pages, uh, are present on my vector database, which I've previously got from my FTP server. So as you can see, we also ingested all the metadata along with the data itself to make sure that the AI model is able to provide insightful citations and make sure you know where the data is coming from. This is able to reduce hallucinations. You are able to understand if the data is indeed correct. If you want to do a cross fact check, you can also do that by instantly searching for these documents on your FTP server or on your vector database as well. So I can ask different questions such as maybe what were the key findings of the court regarding the App Store policies? So for the ones who don't know, this was basically a court legal case in which Epic Games was complaining about Apple's uh, restrictive policies on the App Store that were preventing them to effectively publish their games freely on their App Store. So as you can see right now, we have a lot of information regarding these legal case between Epic and Apple. And if I were to do that manually, I would have to search for many, many different documents on this SFTP server. That would take a long, long time for me, and it would be a lot of work to do. Here, I can instantly query an LLM and would automatically stitch the context together to make sure that I have insights out of the box right away in a matter of a few seconds. So it is able to increase performance and productivity if you leverage this for many, many different use cases. Maybe you have some internal company knowledge you want to leverage an LLM to get information from. Maybe you have legal documents as well, or any kind of PDF document, or even further, maybe you have data scattered across SQL databases, APIs, even on the internet. Maybe you want to access that in real-time APIs, and you want to mix all of that, you can infinitely add new next sets here. And you can search for example, if I wanted to get news, I could get that from the news API that I've connected to. And you can infinitely stitch different contexts and more context as you might need to. So as you can see here, we have a lot of information regarding this legal use case, but this is just an example of how powerful it is, this framework that enables you to get any information from anywhere and basically get instant insights from it using multiple different AI models and LLMs. I would also add that this is also available through an API, which means that if you don't want to use this interface that you're seeing right now, and by the way, this is available to all of our customers that use Nexla's GenAI offerings, you can also use our API to basically have the same mechanism out of the box to be able to instantly query your provided next sets using LLMs. So we get you an API endpoint in which you can easily connect to any front end and make your users uh, be able to query any LLM of choice using our own data. Okay, so we've covered a lot today, and now I'd love to open the floor for any questions you might have, whether it's about Nexla's integration capabilities, our RAG framework, or how you can leverage our platform for GenAI needs. Ask away. Thank you for joining us today. I hope you'll find the session insightful and are as excited as I am about the possibilities that Nexla offers for scaling GenAI applications. Don't forget to check out our free trial to explore these features hands-on. Here you have the URL in which you can easily sign on for a free trial, and you have the access to this chatbot interface that I just showed you and all the capabilities that I showed you on the demo. Within a few minutes, you'll be able to quickly connect to your data sources and start streaming data into your vector databases, and also asking questions about your data. Thank you. Okay, so um, if we have any questions, feel free to reach out on the chat window. I'll be happy to answer all of them. And by the way, I know I just said it, but uh, if you want to try to connect your data sources right away to instantly query them using this chatbot interface that I just showed you, it's that URL that you're seeing right now on your screen. You can sign up for a free trial, and using genai.nexla.com, you would be able to see that interface. And once you start connecting to your sources, creating your next sets, you would be instantly able to query them using uh, our chatbot interface. So yeah, make sure you check that out as well. So do we have any questions? Okay, so I have a question. Uh, the question is, how can I use Nexla for private data analytics? Do I rent or subscribe for access? Uh, so okay, so Nexla is able to access different data sources. So Nexla is a SaaS platform. We are a cloud-based solution. So if you're your data analytics source is available through the internet, we can instantly connect to that using the Nexla platform. We're on the cloud, so if that requires VPN or maybe private link or maybe SSH tunneling, if that's private to your organization, maybe it's an on-prem solution, we can also connect to these systems if needed. It's just a matter of understanding your infrastructure, but Nexla can reach data at many different places. Whenever being available on their internet or not, we can easily access them. So yeah, I have some other one. Is Can you explain the flexibility that Nexla provides in integrating data from different formats and sources, like combining PDFs with SQL databases? Yeah, so on our GenAI offering, that interface that you've seen me demonstrating, that chatbot, and also over the API, we do have some query rewriting and re-ranking strategies to make sure that whenever we get a question from a user, and you have many different connected next sets being with different formats, so one of them might be your repository of PDF documents, other one might be your SQL server or any structured data source. Our query rewriting and re-ranking strategies and mechanisms will take the user query and understand from where that information might be present. So based on all of your connected next sets, all of your connected sources, our AI models can understand from where it would be better to get that answer from. So if the user is asking for like KPIs, for instance, probably our AI models would understand that the structured data source would be better for that use case. If the user is asking for something like a meeting summary, probably the PDFs source would be a better source of information to get that data from. So it's entirely handled by our query rewriting and re-ranking mechanisms. So another question, how do I select or ensure which LLM fits better than other for a specific industry use case? That's a good question. So, I think the first step to choose your LLM would be to effectively test a lot and that's why Nexla provides that framework and that playground of being able to instantly query your data with many different models, because you can easily evaluate and compare different models for your use case, right? So for some models, for some use cases, maybe OpenAI would perform best, and for some others, maybe it's Mistral. So we don't give you an answer. We don't say, hey, for financial, you might use that, and for this use case, you might use the other one. We don't give you that. We might give you advice on what we've seen before, and we can help you. We can support you over that implementation phase. But we'd like to give you the flexibility of like testing and comparing and experimenting with many different models. And a follow-up question on that is, how do I compare and contrast the LLMs, economics or efficiencies for a given specific use case? Yeah, that's another good question. So, it all depends on what you feel, what to take into consideration as performance. So, for some people, LLMs that reply with a long text excerpt might be better, and for other people, they prefer a more straightforward and concise response. So that evaluation is individual to each use case and to each company. So it solely depends on how is your strategy to leveraging these LLMs. But of course, we do have the efficiency part, right? The economics part as well, and it's also the efficiency part, which is basically the price per token, right? So if your context is huge, you have like a lot of documents, a lot of PDFs, a lot of data you want to stitch together to send that context over to the LLM, maybe choosing an LLM that has a lower price per token would be ideal. Yeah, because of course you're also looking into the price per token of each LLM and how often you're going to call that LLM with your data. So you want to take that into consideration. So what we usually do is like we run a lot of tests on top of every data, we get feedback from users. So you've seen before on that chatbot screen that we do have like a feedback interface that asks, hey, was this helpful or not? And then the user can answer that, and we can put that on a table saying, hey, these were the best performing LLMs, and this is the price per token on these LLMs, and you can easily get a grasp of what would be ideal for your use case based on the performance and also efficiency economically of these LLMs. So I know I said a lot of things, but in the end of the day, it comes to every specific use case, every preference of what would be an ideal response, and also the price per token that you want to be committed to. One thing I might want to say and add to that is that every user on Nexla has free access to these models that I just showed on the chatbot screen. So the experimentation part that you're using with these models, it's all free. You can use that included on your Nexla subscription. So if you just want to explore, you might not want to go over the hustle of registering on every LLM provider and getting an API key for every LLM provider. You don't need to do that because Nexla provides you with our own private uh, models of every provider that you see on that screen. So experimenting is free. Yeah. Anything else? Okay. Well, I wanted to thank you once more for joining us today on this webinar. I'm available if you have any questions, feel free to reach out. My email is gabriel.campos at nexla.com. You can also reach out to sales@nexla.com, and we'll be sure to help you. Oh, there's another question. As I go through the trial and come up with questions or issues, how do I get support? Yeah, that's a good question. So we do have our it depends on which questions you have, of course, but we do have our sales@nexla.com email. We do have our contact email, and we do have support@nexla.com as well. So you can reach out to us mainly through email, um, and we probably will help you along the way. And if you want a specific demo, maybe tailored to your use case, I know you're running a trial, but probably you have something in mind, and on the trial itself, it might be too limited for you to really test everything. Send us an email on sales@nexla.com, and we'll be sure to go over a demo with you and maybe provide you with a more structured trial environment where you can maybe run a POV. We can assist you with a POV, and then you can properly evaluate better. Great. Anything else? Okay. Great. So I think we're good on the live questions. Again, thank you very much for joining us today. I'm available if you have any further questions. Reach out to me over email, gabriel.campos@nexla.com. I think this will also be available as a recording. So if you want to rewatch this, we're gonna send you a link over email. And yeah, that's it. Thank you very much for joining, everyone. Have a nice day.